Good evening, and you're all very welcome to this evening's webinar, which is being brought to you tonight by the Teagasc Mayo advisory staff. My name is Brendan Gary. I work in Teagasc and Ballinrobe, and tonight, for the next hour, I'm delighted to be your host on this Thursday evening. Now, this evening's webinar is the final episode in the new 4-part series of webinars, which have been running over the last few weeks, and the series will conclude tonight. Now, during this new series, we have covered some key agricultural issues facing Irish farmers in 2024, and tonight will be no different. Tonight, we will look at two very important environmental issues which affect every farmer in this country. Our first speaker tonight will be Climate Change and Sustainability Advisor Enda Geoghegan from Teagasc and Ballina, and Enda is going to provide us with the latest information in relation to sustainable farming practices. While later, Peter Comer, an ASSAP advisor based in Teagasc and Ballina, and Peter will be talking to us about the new Better Farming for Water campaign launched by Teagasc a number of months ago. So stay tuned for that. Now, you, the viewers, have been encouraged to engage with our speakers here tonight. We ask you to type your questions into the Q&A button at the bottom of your screens, phones or tablets. And later this evening, Vivian Silk, the Teagasc Regional Manager here in County Mayo, will put your questions live to both Peter and Enda. So do type your questions in throughout the night. As always, this webinar is being recorded and it will be available to watch back on the Teagasc Mayo YouTube channel in the coming days. So without further delay, I'll now ask you, Enda, to start sharing your presentation with us, and it's over to you now, Enda.
Yeah, thank you very much, Brendan. Um,
That's great, Enda. Thank you very much, Enda. Over to you
okay,
now.
thanks very much, Brendan. Yeah, as Brendan said there, I'm Enda Geoghegan. I'm the Climate Change and Sustainability Advisor for the region here. And we're working as part of the Signpost Advisory Programme. And basically, we'll say what I'll be talking about tonight is about reducing emissions on your farm. And really, when we were talking about reducing emissions, we're talking about simple things that people can do to reduce emissions. Now, many of these things people are doing already, but just to start off, we'll say, I suppose the starting point with the talk tonight, when we're talking about reducing emissions on the farm, is the whole area of fertilizer planning. Now, when we're talking about fertilizer planning, it is a starting point, but it's also a very important issue too, for a number of reasons, as well as for the environment and for, we'll say, climate change and reducing the amount of CO2 that's being emitted into the atmosphere. There is, we'll say, rules and regulations around the amount of P that you can spread on any farm. And since last year, everybody would have registered for the fertilizer register. So the Department of Agriculture will be aware of the amount of fertilizer farmers are spreading. So look at when you get your soil samples taken, just sit down and have a chat with your advisor and make sure you know the P limits for your farm there for your own particular farm, because with the fertilizer register, it is going to be very easy to detect people that is exceeding the P limit there. But we'll say in terms of emissions, if we get back to that there, soil fertility is the key component in reducing farm emissions. So basically, we'll say if your soil fertility is right, you're going to be spreading less fertilizer. And if you're spreading less fertilizer, obviously there'll be less fertilizer being produced, less fertilizer being transported around the country. We'll say emissions will come down. So when we're talking about we're talking about using a planning tool such as your nutrient management plan. So when you get your soil samples taken, the soil samples will signify, we'll say the levels of NP and K in your soil. They'll also signify the amount of lime that's required. So we'll say when you're putting all this information into your nutrient management plan. The nutrient management plan will allow you to plan the amount of lime that has to be spread over the farm. It'll also, will say, give you the opportunity to optimize your soil fertility. by targeting, we'll say, fields which needs P's and K's. Also, you can target the use of cattle slurry and farmyard manure. And indeed, you'll be able to select sustainable fertilizers. So replacing CAN with protected urea is very important, and it's one of the biggest issues here. Um, we'll say I'll be covering that a little bit later on. Anyway, we'll say the advantages of the protected urea, but protected urea versus CAN will reduce emissions by 8% simply by changing the type of fertilizer you spread. And indeed, replacing your cut swart and your pasture swart with 18612 and 101020, this will also reduce the amount of emissions because the type of nitrogen that's used in the likes of 18612 and 101020, it's a different type of nitrogen than in the 24 2.5 tens. So it's a more stable type of nitrogen. So there is going to be less nitrous oxide emitted from the likes of 18612 and 101020. But the 24s and 27s, there's developments, we'll say, being carried out in them, and you will find the nitrogen element of that in the next few years will be probably protected urea. So things are, we'll say, changing, and they're changing fairly rapid in terms of fertilizer formulations. We'd also be recommending, we'll say, sulfur to be spread with any of these nitrogen products because we'll say sulfur will improve the N efficiency on the farm. So it'll improve the amount of N that is being utilized on the farm. So look, at agriculture is one of the only sectors in the whole economy that has a plan in place. So we have a plan in place how to reduce our emissions by 25% by 2030 without, we'll say, affecting our production. And this, we'll say, plan is, we'll say, based on changing the type of fertilizer we use, improving breeding, shortening, that we'll say, finishing cattle quicker, making sure that all animals will say go back and calf, um, by, we'll say, having soil tests, and then there's new developments there, and there's actions that's been developed all the time. And one of them actions there that is being developed is feed additives. And we'll say when we're talking about feed additives, this is an additive that's incorporated into the feed, which will reduce the amount of methane that animals produce. And we'll say then down the road again further, then there's possibilities of breeding, we'll say, animals that will emit less methane. And we'll say there's also investigations into feed additives that can be, we'll say, spread on the pasture itself. So there's a whole lot of things, we'll say, being looked at in order to reach um that I suppose ultimate destination that we have by 2050, that we are going to be carbon neutral in agriculture. The marginal abatement cost curve is this curve, and basically what this is, it addresses and shows all the actions that is available there, and it shows whether these actions are going to be costing the farmer or they're going to be of benefit to the farmer. Now, most of them will say, of benefit to the farmer, but some of them will say will have a cost implication on them, but all of them will reduce the amount of emissions on the farm. So anything that is below the line is a cost, while anything below the line, we'll say, is a benefit to the farmer, while anything above the line will initially cost the farmer there. But in, we'll say, agriculture, when we're talking about agriculture, I suppose we're talking about three main types of greenhouse gas. We're talking about CO2, we're talking about methane, and we're talking about nitrous oxide. So we'll say when we're talking about methane, the biggest emitters of the greenhouse gas there from agriculture is your livestock, which is working out about 63%. But the next one then is your whole area of your agricultural soils, which incorporates your chemical fertilizer and your lime. And what that is coming in at there, that's coming in at in and around 18.3%. So that's what we're sort of focused on here tonight. So when we focus on this, we're talking about the soil test as being the starting point to look at how you can reduce your emissions. And while you're reducing your emissions, you're going to actually increase the production levels on the farm. You're going to be growing, we'll say, more or the same amount of grass with less fertilizer. And if you are spreading less fertilizer, two things are going to happen. Number one, you're going to have less emissions, but number two, you're not going to be wasting money on fertilizer you don't need. And number three, you're going to keep within all the regulations as set out in the nitrates, and also you're going to be keeping within the regulations that's on your farm. As I was saying earlier there, every farm has a P limit, so just to keep an eye on them. So when you look at the soil samples, you'll be looking at the lime status, you'll be looking at the phosphate status, and you'll be looking at the K status or the potash status. So we'll say your nutrient management plan, if you decide to get one drawn up with your soil samples, will provide all this information in a very easy to read fashion there. And there's an example there on the screen of a nutrient management plan, and you can see there the overall fertility status of the farm. You can see, we'll say, the pH levels on the farm and how much of the farm we'll say is in the ideal pH there. In this case, we'll say we've 10.99 hectares in 6.2 to 6.5 pH, which is the ideal pH for grass production. So implementing a lime plan, it's one of the cheapest things that you can do is to spread lime, even though we'll say with the recent liming scheme there, that lime price has probably gone up. It's still one of the most cheapest things there that you can do. The ideal pH for grassland, as I said there earlier, was 6.3 to 6.5. Clover, if you're incorporating clover into a sward, you need it at 6.5 to 6.8. Your grassland soils. Now, if your pH is correct, your grassland soils will release up to about 80 kilograms of nitrogen per hectare per year, and it'll also increase the soil P availability. So you are going to save money as a result of spreading lime. You're going to reduce the amount of fertilizer you need, and we'll say maintaining higher, we'll say pH is going to reduce the nitrous oxide emissions into the atmosphere. So lime cannot be overemphasized how important it is in your fertilizer planning. So put a lime plan in place and discuss it regularly with your advisor. Now your P and K planning then is also very important, and we'll say your P and K planning, it's just to make use of the information that's within the plan. There's no point over the years people has taken soil samples, and one of the biggest failings of farmers with soil samples sometimes is that we don't make use of them. We don't make use of the information that's contained in them. So with the fertilizer register, it's becoming more and more important that we are very familiar what information is within them and how to use them. So make use of a plan. Target your soils that are P index target your soil that you will achieve a P index of 3. That's the ideal P index for soils. And it's when your soils are at the optimum level of P and K, and indeed lime, what you will find is you will find that you will get more efficient use or more nitrogen use efficiency from your nitrogen. So basically, we'll say if your soils are ideal for P and K and ideal for lime, you could be getting benefit of up to about 80% of your fertilizer, whereas low pH and low P and K levels down at index 1, you might be only getting benefit of 35-40% of your fertilizer. So indeed, that is a big, we'll say, difference there. In other words, you could be spreading a bag of 18612 to the acre and you might be only getting benefit of 50% of it versus, we'll say, ideal soil pH, ideal P and K, you're getting benefit of up to 80% of it. So again, you're growing the same amount of grass with less fertilizer. When we're talking about compound fertilizers, we're talking about the likes of 18612, 101020, which is very important to maintain your P and K levels. But we'll say aim to use your 18612, your 101020 type, rather than your cut sward or pasture sward, unless they're the new protected urea based cut sward or pasture sward. Aim to use the 18612s. It's a more stable form of a way of getting your P's and K's out there. Um, so we'll say that's just there with the compounds. It's very important to keep an eye to your P's and K's in your soil samples. Efficient use of organic fertilizers, how you spread your slurry, and the timing of how you spread your slurry is very important. So whether you use low emissions, you get your slurry out early in the spring, very important. If you target low index soils, P1s and 2s, you're going to find that you will get using your low emissions slurry spreading techniques, you will get an extra 35 to 65% of nitrogen out of your slurry. Test your slurry. It's a relatively simple test to test your slurry, whether you test a sample of slurry early in the spring, know what you're spreading in the spring there, know what you're putting out. It's very easy to do. And also we'd be recommended apply in the springtime when you will get the maximum bang from your buck from your slurry. But that is very much, as Peter will be focusing on in the next talk, very much dependent on ground and weather conditions. Keep enough slurry for the silage fields, very important. The next one that we're going on to is, we'll say, the whole area of protected urea. So changing your fertilizer type, changing over to protected urea. Very simple thing to do. You're going to save yourself money. 20% of a saving for between can versus protected urea. So your protected urea is 20% cheaper than your can and is 8% less emissions out of it. So it's a win-win situation there. Protected urea, because it's protected, it can be used throughout the year and it can be used the very same as can. That's a very important thing to think of there. Ordinary urea, you were only able to use it the shoulders of the year, we'll say dull, damp conditions, but with the protected urea, you can use it throughout the year. Use it the very same as can, and there is no problem, we'll say, with availability of it. Indeed, some people say, oh, protected urea is it's dearer than can. Can is cheaper per ton. Just an example here, sometimes a picture tells 1,000 words. If you look at a farmer there, 5 ton of can, it's costing them €2,000. 3 ton of protected urea costing 1620. It's the very same amount of nitrogen in both the products. So it's a saving of €380 to use the protected urea. You're going to be reducing your emissions by 8%, and um, it's a win-win situation there. Good for the environment and good for your pocket. So we'll say with the fertilizer policy between now and 2030, I suppose what we'd be recommending people to do is to aim to maintain current production with while using less, we'll say, chemical fertilizers. How do you do that? Get your soil samples taken. Use your soil samples. Become familiar with them. Spread lime where it's required. Increase use of the NBPT urea products, which is the protected urea. It's sustainable and it's the lowest form of N, cost of N per unit of nitrogen. Move away from your cut sward and pasture sward. It's an expensive way to get the P and Ks out there, and it's not benefiting the climate, not good for the climate, because, as I said, um, there's a different form of nitrogen there, which emits more nitrous oxide than your 18612s. But again, as I was saying, these products are changing, and in the next few years, you will find your cut sward and your pasture sward will be the protected urea based, will be the N element of it. Use applied nutrients as efficient as possible. The four R's that we're talking about, it's the right place, the right product, the right conditions, and the right time. So that's the four R's there. Right place, right time, right product, and right conditions. Recommended sulfur to improve the nitrogen use efficiency and reduce the fertilizer rate. And reducing the farm N surplus will increase the N use efficiency there. So look at the main points here that we want to get people to look at. Very easy way to reduce emissions on your farm while benefiting your pocket, maintaining production, and being good for the environment. Correct your soil pH, spread lime if it's needed. Take your soil samples, look at your soil samples, implement a nutrient management plan on your farm. Select your fertilizer type to, we'll say, with a view of reducing emissions on the farm. Target your slurry to your silage fields and target it to your P and K 1 and 2 indexes, which is needed, and it will really improve the P and K situation on them fields, and also reduce the chemical N. Reducing the chemical N, if you spread your slurry early in the year, you have your lime levels right, your soil samples taken, you'll be doing that automatically. So look, that's it for the presentation. Thank you very much for listening, and I'll be able to handle any questions later on when Peter's presentation is over. So back to you there, Brendan. I'll stop sharing now.
Thank you very much, Enda. Indeed, look at it's a great presentation there, Enda. And indeed, just a reminder again to our listeners tonight, with a lot of farmers on, if you could please type your questions in there to the Q&A tab, and later this evening, Vivian will pick those questions up. So at this stage of the evening, I'll now ask our next speaker, which is Peter Comer, to start sharing your presentation with us. And Peter, it's over to you now, Peter. That's great now, Peter. Thank you very much, Peter.
Okay, so good evening, everybody. Peter Comer is my name. I'm a Teagasc ASSAP advisor here in Mayo. And tonight's talk on water quality, it's better farming for water, 8 actions for change. This program, as Brendan said, was launched there earlier in the year, really to try and reverse the problem with water quality deteriorating, and is in danger maybe of losing the derogation altogether. So I'll just do a quick run through the background, why it was brought in. Then the main thing is the 8 actions for change. Quick look at some key impacts, and an even quicker look at some of the drivers there. So The background, well, the Water Framework Directive, it's all hinges on that. That was brought in the year 2000, so it's there a long time now. And the target there was to have all waters at good to high quality. That's Q4 and Q5 by 2027. And of course, we're a long way off that yet. Running alongside that with the Nitrates Directive, which is there even longer. We're currently on our 5th Nitrates Action Plan, and that, of course, is mainly directed at improving water quality. It's all the actions farmers have to take, and you have all your cross compliance inspections and that. But again, it hasn't really worked. It hasn't improved water quality. We have water quality has been going down every year. On average, at 3% a year, we're losing our good and high water quality marks. So not really working. Then, of course, it was all brought to a head there recently when we lost our derogation from 250 down to 220. So most of the country is now operating at the 220 kilograms organic nitrogen per hectare. If you're not in derogation, you can farm up to 170, which does cover most farmers, but some like to be higher stocked. So the 220, it would be very important, especially for the dairy side of things, to hold on to the 220. So I suppose that's a huge impetus in this farming for water 8 actions for change. And if we quick look at the latest EPA report there, 54% of our surface waters are good, but that in turn means 46% are not good, are not satisfactory, are not meeting the targets under the Water Framework Directive. And looking at 2022, 44% of rivers were above the nitrates threshold of 8 milligrams per litre, and 25% of our rivers were above the 0.035 phosphorus limit. So nitrogen and phosphorus, they're two nutrients that we don't want to be getting into our waters, because the good bugs in the rivers, they can't survive where there's high nitrate and phosphorus. And when you get nitrate and phosphorus coming together, it leads to eutrophication or algal blooms. We also saw what happened in Lough Neagh last year and again this year, and of course in our own estuaries especially, we get lots of algal blooms and lots of mosses and stuff in rivers. So we're trying to avoid that. And as well as the N and the P getting into rivers, we don't want to be letting sediments in, sediments, clay or peaty sediments, because they murky the water and again make it impossible for the good organisms to live in the water. And of course, they also carry nutrients with them. So it's a double blow there when sediments get in. We want to keep pathogens out of the water, so no slurry getting in or no animals in and defecating in the water. And also pesticides, a huge issue. We want to keep them out of the water, especially when it comes to humans and drinking. We have MCPA mostly here in the west, but in the tillage areas, you have loads of pesticides. Some of them might get in, and in intensive grassland, you could have all the dock sprays. They have a potential to get in, along with maybe some glyphosate products. And again, this campaign, Better Farming for Water, it's building on other programs like the ACP or the catchments program, where there's 6 catchments around the country, really measuring everything that leaves the catchment. So great science there, and we'll be certainly using that going forward. Then we'll be leaning heavily on the ASSAP program and the Farming for Water EIP. There to implement the changes in this program. ASSAP, that program was set up in 2018 to try and give free advice to farmers on how to improve water quality, and will be instrumental in implementing this Farming for Water EIP. This could be a game changer in that there's 60 million funding there, 50 million for farmers, for measures directly helping to improve water quality. Initially, we're starting off where the waters are maybe at Q3 and Q2, but eventually I suppose it'll be open to everybody to get grant aid for things like fencing and buffer zones and all the usual things that help to improve water quality. Okay, yeah, the blue dots, that's for the pristine waters, the Q5s. we're building on the acres. There's water quality measures there. Waters of Life, Cheerlawn have their Slaney project. And then there's a plethora of other EIP and life projects that help improve water quality. Here in Mayo, you have Cara Life, which is totally devoted to improving water quality in Cara Lake. So getting on to the meat of the thing then, the Better Farming for Water, 8 actions for change. We have it's divided in 3 there: nutrient management, 3 actions; farmyard management, 3 actions; and land management, 3 actions. So looking at the nutrient management, number 1 there is to reduce our purchased nitrogen and phosphorus surpluses per hectare on farm. So it's not saying don't buy in or P, it's saying don't buy too much of it, more that you're actually using. So Enda talked a bit about that, the nitrogen use efficiency. The thing with nitrogen is it's use it or lose it. So if there's a surplus of nitrogen, it either goes up into the atmosphere or down into the groundwater, leaching mostly. So you just need to put it out, the right product at the right time, so that the crop uses it and there's no spare nitrogen hanging about. The same with phosphorus. We say, yeah, bring your soils up to index 3 for P, where you're fairly well stocked. Don't be making index 4 a target, because then you're going to have surplus P in the system and a high risk of leaching. And if you're lowly stocked or less intensive, index 2 should be the target. There's no great urgency to get up to index 3. Moving on to number 2, in soil fertility is optimal for lime, P and K. Enda's that well covered. Obviously, if they're good for lime, P and K, you're going to get much better nitrogen use efficiency, so less scope for nitrogen leaching down into the groundwater. And the lime then on its own, well, that's critical to release phosphorus and potassium in the soil. So if you want to make more phosphorus available for use by the plant, well, then make sure you get the pH right, get it up to 6.3 if possible. That will release phosphorus readily available to the plant. It means you have to be putting out less of it, so less risk of runoff into the water drainage network. The third one there, ensure the application of fertilizer and organic manure at appropriate times and places. Again, Enda mentioned that, but really, you want to be putting these products out when there's good growth there, and when the weather is right, and when the soil travel conditions are right, the ground conditions. So again, with your fertilizer, chemical fertilizer, we're trying, especially the nitrogen, hold off in the spring until there's a bit of growth there, because once the growth comes, the grass can take up the nitrogen. And again, don't be going too late in the autumn with heavy doses of nitrogen, especially because there is mineralization there, and as Enda said, the lime as well. If that's right, the soil itself will be releasing nitrogen, so you don't want to hold a load of nitrogen there in the back end to be washed away or leached during the winter months. And again, with your slurry, you don't want to be going 16th of January when the season opens. Ideally, wait for the growth to come. If there isn't growth there, the slurry is no good. The grass roots has to take up the slurry. That's what makes it safe. And of course, the critical one as well is to watch the weather front conditions. No heavy rain forecast inside 48 or preferably 72 hours. And make sure the soil isn't waterlogged when you're spreading. So they're all critical things, really, especially here in the West, to keep nutrients out of our waterways. Okay, the next then, moving on to the farmyard. Have you sufficient slurry and soiled water storage? Right. Well, this is of course critical, and with all the TAMS grants now and all the schemes that have been around for the last 20, 30 years, in fairness, there's a lot of slurry storage there built up, but not everybody has it, and especially those that have expanded recently, maybe quite short on slurry storage. But I mean, the more storage you have, it means the more buffer you have. So the slurry isn't coming up in the slats in January, and you're waiting for the 16th of January to get out with your slurry. You have that buffer to hold off until March, maybe when the ground is drying up, and when the weather conditions and the ground conditions are better, and you know that there's much less risk of leaching and runoff of especially of your pee. So it's important to have a buffer there in the terms of storage. And with the soiled water, well, as you know, that's mostly for dairy farmers. They now you can't now spread this month, the month of December, 4 weeks storage is required, whereas it used to be just 10 days one time. Okay, number 5 is manage and minimize nutrient loss from farmyards and roadways. So again, critical. This was always the case. There should have been no runoff of slurry or any nutrients or dirty water from your farmyard. So in fairness, right, a lot of improvements there, but still, I suppose a bit of a way to go. You'll often see on the non-dairy farms, you'll see heaps of farmyard manure uncovered and the runoff running off down into the paddock and maybe a drain close by. So then some yards are very dirty, and you'll get runoff from that, whether it's tractor wheels or loose silage or whatever. And indeed, in other yards, there might be some cattle fed in a ring feeder out in the yard. So that causes problems if the runoff isn't being collected. So that's called point source pollution. Vital to prevent that. And of course, recently every farmer and every farm roadway, there's a rule there now where there should be no runoff from a farm roadway into a drain. So if you have a roadway running alongside a drain, you have to camber it away from the drain. That rule is there for the last year or two. So there's on the left, runoff from a farmyard there, somehow effluent coming from bales and stuff. And a dirty yard. So that's going off there. Even if there's no drain nearby, it's not great because it's going to get its way down into the groundwater eventually, or it'll form a preferential pathway to a drain. But often there's a drain near the farmyard and it'll just wash its way in. On the right, the farm roadway there, and that's just a point where it's crossing a culvert crossing actually. So there's a drain underneath it there, and as you can see, the farmer made a hole there to let the runoff into the drain. So work there to be done to improve that roadway and make sure that there's nothing getting into the drain. That's law now. There should be no runoff of nutrients or sediment into the nearby drain. Right, so land management then, there's 3 actions there. First one, fence off the watercourse to prevent animals getting in. Well, that's a no-brainer. When animals, or indeed sheep either, if they're racing along the side of the bank and they're going into the stream, they're pulling the bank in, creating huge amounts of sediment. And of course, the animals, if they're in drinking, then the cattle, well, they're defecating in the water, and as well as introducing nutrients, they're also introducing pathogens. So we want to prevent that. And by the way, for a lot of these actions that I've mentioned, there is funding there now under this EIP program, the European, as I say, the 50 million. So if you're not getting funded by some other area, such as acres, there's a possibility that you get funding under the EIP program. As I say, we're working mostly where the waters are at moderate to poor quality at the minute, but I suppose in time it'll be open to every place. So number 7 there, promote the targeted use of mitigation actions such as riparian margins and buffer strips. They're very important to make the river or the stream safe. The buffer strips are that safe zone. As you know, there's a buffer strip. There's a mandatory one there if you're spreading slurry. It's mostly 5 meters. Sometimes it can be 10 or more at times. For chemical fertilizer, it's 3 meters. You have to be back from the drain or the water course. And sediment traps, they're important, especially if you're cleaning drains. Try and leave the last 20 meters uncleaned for a while anyhow, until it catches all the sediment. Or some people might put in a straw bale there, something to just trap the sediment, not let a whole load of it off into the nearby river if you're doing a lot of drain maintenance. And the last one then, maintain an overwinter green cover to reduce nutrient leaching from tillage soils. So yeah, very important on tillage soils. In the West, you could convert tillage soils and you could say, well, don't be overwintering cattle or don't be badly poaching your ground over the winter because that gives you the same effect. So right, so there's a drinking point there before and then after a solar pump was installed, the drinking point was closed up and the fencing was put in, sheep fencing there. So that was an excellent job there to protect that stream. You can't see the drinking trough because it's over to the right-hand side, 20 meters away. That's the recommendation, is to keep it back 20 meters, not to have it at the edge of the drain. So that was an excellent job there. The good buffer zone there, that's ideal. That slurry, as long as it doesn't team rain, and even some rain, it'll still won't be a huge threat, because there's a nice buffer there, and you can see a nice lot of rough grass there. So there's a low risk of runoff there in that field getting into the drain there. A lovely buffer used there. So don't be going up to the edge of the drain. Watch your buffer zones. On the right there, you see severe poaching where, well, their animals were grazing a cover crop over the winter, but that could be a field where a farmer had a ring feeder, and you'll see the same thing. So no green cover there, you could say, over the winter, and so it's high risk of loss into the nearby drain or stream with the rainfall that we get. Right. So that's the thrust of the 8 actions then. So what are the key impacts there that we're looking for? Well, we're hoping to enhance farmers' knowledge of local water quality and pollution. So again, the ASSAP advisors, or indeed any advisor, should be able to show farmers their local water quality and what are the pollution pressures, and I'll show that in a minute. Of course, the key impact is if we reduce the nutrient, sediment, pesticide, and pathogen loss to water. That's obviously what we're looking to do. And then finally, if we can increase the proportion of our rivers, river water bodies where agriculture is the main threat, if we can increase that proportion of Q4 and Q5s, well, that'll be a win-win there. We'll be meeting the target for the Water Framework Directive, and it'll certainly help our case in holding on to the 220 derogation. All right, so the Farming for Water Quality, the programme, it's built on 6 pillars there. I'm not going to go through in detail them all, but just maybe the stakeholder engagement there. Here you have the farmer, but we're trying to get everybody involved along the way that interacts with the farmer. So whether it's farm organisations, the government themselves, the buyer, the meat processors, they might give bonuses to improve water quality. Of course, you have the local authorities, and LawPro are huge there. The environmental regulator, the EPA, vital. Then advisors. So you have ASSAP advisors like myself. You have all other Teagasc advisors, we say, and you have all the private advisors and indeed co-op advisors. All should be singing off the same hymn sheet to give the same message to try and improve water quality. It's no good if one is given one message and somebody else contradicts it a week later. The farmer will be just totally confused. Research is very important, and as I say, the ACP program is doing vital work there, but you also have other trials in Johnstown and Moore Park connected with water quality. And the agri-input suppliers, they are absolutely vital, because sometimes they're the main ones that the farmer meets when he goes in to buy his spray or his fertilizer. We want the agri input suppliers to be knowledgeable on what's best for that farmer and what's good for the environment as well, and not to be giving them the wrong product. Okay, then building awareness as well. This is where we're showing the farmer where he can get his own get details on the water quality in his local stream. So that website there, www.catchments.ie, it's all farmers should be able to get into that and be able to navigate it. So there's the water quality map from the EPA. The blue ones are the Q5s, the high pristine water rivers. The green ones are the Q4s. They're good, so both of them are good for the Water Framework Directive. But then the ones that aren't are the yellow ones. They're Q3, and the brown ones are Q2. Thankfully, there's no red one, which is bad. There's no red one on that. So that's good for everybody to know there. Also, you have these pollution impact potential pollution potential maps for P. Again, the dark areas are the areas where phosphorus is most likely to leach. Again, that'll be on heavy wet soils, on peaty type soils, and again, you can show the farmer if his soils are potentially high risk for P leaching, and for nitrate as well. You have the pip maps for nitrate. Again, the very dark ones there, they're free draining soils. It's sort of the opposite to P, the P ones, free draining and highly stocked as well. They're linked to stocking rate. Flow delivery paths as well, that's on the EPA. That shows you can pick out your field and it shows you where the most likely impact is of putting in a barrier to stuff, because it shows the flow pathways, because not the whole field doesn't go into a stream at all along the stream evenly. It goes in at a particular point. So that's showing that, and it's great to be able to show that to a farmer. And
Just another
these are
minute or so, Peter, now.
right a minute, yeah. These are
Minute
the
or two.
things we're trying to protect. These are the mayfly, the stonefly, caddisfly, and these are what they call the good bugs or macroinvertebrates. These will only live in clean waters. So if the water is polluted, whether it's nitrate, phosphorus, or sediments or pesticide, these lads won't live in it, and you'll get the other bad guys in it, like the worms, the leeches, the slugs, or whatever. And these are the ones that the fish need. So it's if you want fish, you have to have these, and that's why we need the Q4 and Q5 waters to keep these guys alive. So that's really it. I mean, I'm not won't go into all of those. Like, we're all going to be involved in upskilling ourselves, all advisors, upskilling the farmers, the knowledge transfers where we give out this information at discussion group meetings and acres courses and the like. And of course, the research, as I said, is critical as well. So really, Brendan, that's it. They're the 8 actions for change. There's a huge urgency now to improve water quality, and hopefully this is going to work.
Well, thank you very much, Peter. A brilliant presentation there and a great way to finish off the series. At this stage, Peter, I'll just get you just to stop sharing your presentation, and I'll call on our regional manager,
Okay.
Vivian Silk there, and Vivian is going to ask the questions there to both Enda and Peter. So over to you now, Vivian, and good evening, Vivian.
Good evening, folks. Thanks, Brendan, for handing me over, and thanks to Peter and Enda for the presentations. Peter, I'll let you clear your throat there for a minute. You presented a lot. So, Enda, the first couple of questions have come in for yourself. Enda, you mentioned the workshops for what you're trying to explain and what you're trying to do. If a farmer wants to attend, how do they go about applying for one of these workshops and for your knowledge?
Yeah, I suppose, look, at the workshops, if they contact any of the local Teagasc offices, or indeed if they go onto the signpost page on the Teagasc website, or indeed on Facebook, they will get a link to the workshops. And basically, a workshop it lasts for about 2 hours, and we'll say what we go through is we go through the AgNav program, and we do up a sustainability plan for them, the 3 actions they can do to reduce their carbon footprint.
Okay. So after the couple of hours with yourself, Enda, does the farmer have something going out the door with him, or what's his next plan, or what's he ready to do?
Yeah, well, basically, we'll say once the workshop is over, we will do up a plan as soon as we can for him, and we'll send it out to him. We'll say either via email or on the post. Hopefully in the next year or that, we will be in a position where if we have tablets where we might be able to do the plan, we'll say there in situ with the farmer, and he'll be going out the door with the plan under his arm.
Okay, so let's just say the board BA quality assurance. Does there have any pluses or minuses for that in terms of having the course done with yourself?
Yeah, indeed, it's actually some of the factories, we'll say Don Meats, have a sustainability program that they're running themselves. It's called Accelerate, and there is a bonus, we'll say, being paid on the actions being achieved, but that's a separate program. But it is using the information from AgNav, and it is based on the participation in one of our workshops as well. So it is beginning to come, and we'll say some of the co-ops as well are beginning to participate with it, and they'll be paying bonuses on it. So there will be advantage from it, we'll say, down the road. Yeah.
Okay, it's gradually making traction.
Yeah.
Yeah. Okay, Peter. Over to you, Peter. So there's a viewer on here and interested in what you're talking about. So the question is the water quality of the Robe or Lough Carra improving or disimproving? Or can you give a stab at that?
Oh yeah, well, the thing about the Robe, let's say, it starts up in Ballyhonus and it goes down to Ballinrobe. So the Robe is divided into what, about 5 sections, I think. So the way Law Pro do it and the EPA is some sections are good and others are at moderate.
Okay.
So around Hollymount now, for example, um, upstream of the bridge is now at Q4. It was Q3 there last year. Now it's Q4. So
Okay.
that must be all my good work. But then the downstream is that's it. Well, that's actually indeterminate at the minute. I think it's a fish issue, and then yeah. So no, the Robe overall, it's not too bad. Uh, we're not working up around the Ballyhonus area yet, so but some of the tributaries I know going into it are at Q2 and Q3.
Okay.
So there are
Okay.
brown tributaries going into the Robe, but the Robe itself is actually classified mostly at Q4 at the minute.
Okay. And
And
you
Lough
mentioned.
Carra, yeah, Lough
Mm,
Carra is at Q4, but uh, there's a slightly different ratings for lakes, so it's not as clear cut. And the thing about Lough Carra is because it's a shallow bottomed, high quality um Carla what do you call it, the the um the crust, the marl crust, it, it needs much lower nutrients levels than a normal, we'll say, water. So
okay.
than the EPA, because that's why the marl crust is deteriorating, because even low levels of nutrients in Lough Carra is enough to cause damage. So that's a more complicated one. Yeah,
Okay.
but
Okay.
under
And
the EPA, it's actually at Q4.
okay. So maybe not terribly easy to answer this, Peter, but I'll ask it anyway. How will you or we know that the water quality element of the acres, I suppose, program is working?
Oh well, yeah, Vivian. Yeah, that's. I don't know if we'll ever know. Like, I'm sure it'll be subject to a PhD Walsh Fellow or student doing some research on it. Sure, that's the only way we will know. Like, I suppose, anecdotally, you'll know from did water quality improve in that area, and but then is it down to the EIP or is it down to acres? I mean, it's going to be very
It's hard to
technical
put a
there,
finger on it.
hard to
Okay.
like. So
Yeah.
I presume someone will have to do a study on it,
Okay.
Vivian.
Okay.
Yeah.
And the last element of this question, Peter, did the Department of Fisheries produce reports on water quality as well as the EPA?
The
Do you know?
Department of Fisheries.
Yeah.
No, they don't. Well, I'm sure they'd produce their own report, but it's not similar to the EPA report. The fisheries reports, I'm sure, concern pollution, the number of pollution instances that they had to deal with during the year.
Okay. Okay. That's
No,
what
I'd
I'd focus
imagine
on.
that yeah, no, it's the EPA that produced the water quality report. They're God in that. It's them that send off the reports to Brussels.
Okay.
But I mean,
Okay.
they do
Okay.
work together, obviously. Yeah.
Yeah. Okay. Okay. Thanks, Peter. Enda, back to you again now. And you did cover it in your presentation, but maybe no harm to repeat it. So, what are the three most common options people are practicing on their farms to reduce emissions?
Yeah, I suppose the three most common ones are, and look at, as I said, an awful lot of these actions that people are doing, they're doing them already. Taking soil samples, spreading lime, and we'll say changing from canned to protected urea. Three simple actions that people can do. It's reducing emissions, but it's also increasing the efficiency on the farm and it's put more money in their pockets as well.
Okay. Okay. Thanks, Enda. Peter, back to you again. Um, how does one apply for the Waters EIP funding? I know you mentioned it, but maybe again, no harm to repeat it.
Yeah. Well, at the minute, it's sort of being operated by the ASSAP advisors, both the Teagasc ones and the Co-op. I forgot to say there's about about what 20, 30 co-op ASSAP advisors now, and they're also implementing the EIP. So, and they're mostly dealing with the dairy farmers. So, see, it's not, as I say, it's not widespread, open to all applications, in that it's been sort of driven by the ASSAP advisors to get farmers into it, because initially we're working and trying to get farmers in that we've been visiting over the past since 2018. So we have those visited, and we had recommended actions, and we're looking to see did they do them, and if they didn't, well, maybe they do them now with some EIP funding.
Okay.
And we're trying to work in areas where the water quality is at moderate or poor, rather than the Q4s and fives. Do you see? But that doesn't rule out us giving money to Q4s and fives. And I'd imagine, because they want to use up, they have to use up 10 million a year. So, if they're in danger of not using that up, they'll open it more widely. But all you have to do is contact your co-op ASSAP advisor, or your Teagasc ASSAP advisor, or indeed any Teagasc advisor, and you will, or probably private planner, get on as well to us ASSAP in ASSAP, and we can put you in, or assess to see if you're eligible.
And is it like the Thames? Is there tranches, or can you play at any stage?
At any stage, yeah. There's no
Okay.
tranches, no. Just
Okay.
trying to use up the money, but the money is for doing work. Do you see? So it's not, you're not making money, it's to cover the cost of the fencing, including your own labor. So we're hoping that you're not going to be out of pocket, and at the same time you'll have done a lot of good.
Okay. Okay. That's fair enough. Okay, Enda, back to you again now. What is the best time of the year to spread slurry to get the maximum benefit from the nutrients in it?
I suppose, look at it, going back to what Peter be saying there, in the springtime, depending on ground and weather conditions, and it's when the plant is actively growing, and ideally, if you could, we'll say, with the low emission slurry spreading, you will get far more benefit from the nitrogen that's contained in the slurry.
Okay. Okay. And just a final question for you, Peter, and we're ready to wrap up then. What determines poor water quality?
Yeah, poor water quality is, well, you have the chemical test and the biology test. So if in the chemical test that they send off to the lab, if it's high in P and N and wrong temperature, wrong pH, or different things like that, that's the chemical test. But the real driver is the biology test. So if they don't find those guys that I showed you there, the mayfly, the caddisfly, the stonefly, if they find, when they do their kick sample, if they find very few of them, and instead they find loads of freshwater shrimp and snails and leeches and things like that like to live in pollution, they're called pollution tolerant species. So it's the proportion of them versus the pollution sensitive species. That determines if it's Q3 or Q4. It's the ratio between them.
Just to finish it out, is the drinking water standard the same as the environmental standard?
Well, funny enough, the drinking water standard is more lax than because we must be able to cope better. Like for the nitrate, for example, is much higher for human consumption than it is. It's up on 12 or something, or much higher, versus 8 for the biological standard, or ecology standard, we'll call it. So yeah, it's actually more strenuous for the ecology, because they can't survive with it. And anyhow, with humans, you have Irish Water and you have all the treatment plants as well. So they try and ensure that they keep us safe.
Thanks, Peter. I'll hand it back to Brendan to wrap it up.
Thank you very much, Vivian. Indeed, we're just about out of time this evening. I'd like to thank our two panelists here this evening, Enda Geoghegan and Peter Comer, tonight, for their help with this webinar, and to you, Vivian, at all as well, for facilitating the questions and answers here tonight, and indeed, most importantly, to you at home this evening for engaging with us tonight, and indeed over the last 4 weeks. We hope you found this webinar beneficial. We'll get the recording uploaded to the Teagasc Mayo YouTube channel in the coming days, so keep an eye out for that. All of the previous 3 webinar episodes are also on the Teagasc Mayo YouTube channel, so do indeed check it out. They're in a good way of passing the long evenings. Before we finish up, I'd like to thank some of my colleagues across the region there who have helped there to promote these webinars by putting up posters, promoting the events in our offices and indeed on local radio and with their farmer clients, and by sending out text there to our farmers across the region. So indeed, thanks again to you all. So with that, I'd like to extend an early Christmas good wish to you all and hope that you'll be back again safe in the new year with us, where we'll have more webinars. So do keep an eye out for that. And with that, it's good night from us all here, and stay safe, folks. Good night now.